Okay, so horizontal asymptotes, or the limit as x approaches positive infinity or negative infinity, but which we've done, but now we're doing it with an eye towards here's the horizontal asymptote and curve sketching. All right, so if we're going to sketch this curve, not only do we need the horizontal asymptotes, we also need the vertical. So let's just discuss them, right? Stuff we've already done, so, and recently as well. All right, so we will say, hey, determine the vertical asymptotes
Oh, no, I got it. It's on the website. Yeah.
Okay, so part A, we're going to start with a little bit of review, just do a little bit of vertical asymptotes, right? So we know that f of x in factored form is 2x squared over x plus 2, x minus 2, which means we have a vertical asymptote where x is negative 2 and one where x is positive 2. Okay, so we have these two vertical asymptotes. And we need to figure out what's the behavior around them, right? So in other words, are they both going up at negative 2? Is one going up and one going down? Or is one going down and one going up? Or are they both going down? So we do the usual stuff, right? We're going to work out the limit as x approaches negative 2 from below, okay, of this thing here, right? So 2x squared over x plus 2, x minus 2. So we have three terms, right? We got to figure out. We know that 2x squared is always what? It's always positive, right? X squared is positive. 2x squared is always positive. So we know that up here we're going to have a positive. Now, let's pick a number. So the number I'm going to use is, so for example, let's use negative 2.01. Okay, so we're below 2, right? We're approaching negative 2 from below, from the negative side. So if we use negative 2.01, what's the sign of this term? It's going to be negative, right? We're adding 2, we're going to get a small negative. And this term is going to be negative 2 minus 2, also negative. And so we end up with a positive over positive, which is positive. And since we know this term is going to 0, then we end up with infinity, right? Positive infinity. And we'll do the same thing 3 more times, right? Limit as x approaches negative 2 from above. So for example, let's use 1.99, negative 1.99 of, and again, 2x squared over x plus 2, x minus 2. So the top is positive. I have negative 1.99 plus 2. That's going to be a very small positive, right? And negative 1 subtract 2, that's all going to be a negative. And so what do we end up with? Negative infinity.
Just for the top one, why is it infinity? Because like the bottom is going to be infinity, so isn't it kind
No,
of
the bottom's going to be 0. This term is going to tend to 0, right? It's going to get very, very small.
Yeah.
Okay. This term, who cares?
Okay.
Just very, very small times 4. Very, very small times negative 4 is very, very small. Yeah. So we're divided by a very small term, right? And whatever this is doesn't matter. It's very small on the bottom. Okay. Extend the page. So now we need to do the same thing again, this time for positive 2. right? So we're going to approach positive 2, the limit. Let's go from below to begin with, right? And like on the assignment, right, you're going to have to enumerate all of these. You're going to have to lay them all out on a test, same deal, right? Show all the work. Don't just, don't do it sort of flippantly, right? I mean, just. And the reason is you want to develop a methodology, right? Which is every time I do one of these questions, I'm just going to go in full detail so that the only way that I know how to do this question is to always go in full detail. As opposed to, I'm just going to, I can just kind of figure this one out, right? Because then when you get to the more complicated one, it's sort of like you lose the ability to be able to do it because you're no longer, but in full details, like I always do this. And therefore, things will always work out for me. So 2 from below, so let's say 1.99. Okay, again, up top, it's always positive. That's going to be positive, right? It's just 3.99. And 1.99 minus 2 is going to be a small negative, right? So think about what this is telling us, right? It's telling us, okay, I've got this asymptote here, and as I approach it from, well, in this case, as I approach this one from below, it's going down. As I approach this one from above, it's going down, right? And that tells us which direction. And the limit as x approaches 2 from above. So again, we're just going to use like 2.01, 2x squared, x plus 2x minus 2. Again, got a positive there. This is going to be like over 4, so it's positive, right? And this is 2, something bigger than 2 minus 2, small positive. And that's going to be positive infinity, right? So, if we sort of summarize, what do we now have? And where are we going to summarize it? Now, let's kind of squish it in here. So, sketch your asymptotes with just a dashed line. There's my asymptote. And let's get this. So, as we approach negative 2 from below, we're going to infinity, so you're doing that. As we approach negative 2 from above, we're going to negative infinity. So that's going down. As we approach 2 from below, we're going to negative infinity and then positive infinity, right? So that's what we're looking at. That's what's happening at the vertical asymptotes. So as part of curve sketching, that's what we have to know, right? You're going to see there's like the 8-step process to curve sketching, right? So first you do this, then you do this, then you do this, right? And then you put it all together, and here's the drawing of the curve, right? So I know what it looks like. Okay. So now, let's worry about the horizontal asymptotes. So that's what happens here, around here. What happens as we go out this way? So let's find out. So B, determine the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x. Right? And interpret these. Values or whatever. So what is it and what does it mean? Okay, that's really what you're really just learning how to think, right? It's just, okay, let's put this together. Let's figure out what's going on here. So the limit as x approaches, now you know what we're going to do? We're going to put them together, plus or minus infinity, okay, of f of x is equal to the limit as x approaches plus or minus infinity. Now, this will hold, but it won't always hold, and we'll look at a case where maybe we don't want to quite do that. 2x squared over x squared minus 4. All right, now, if you think back way back to limits, right? We were doing limits as we approached infinity. And that's in the book somewhere, section 1.6, I think. Then what do? Well, we divide by the highest degree, right? So we're going to divide top and bottom both by x squared. So that is going to give me, and that's why I can use plus or minus infinity, right? We got x squareds here. Okay, so we get 2x squared over x squared. Make that bigger. Over x squared over x squared minus 4 over x squared. Okay, so now we divide out, simplify, limit, and what do we got? We got 2 over 1 minus 4 over x squared. Okay, so what happens to this term? X squared gets really, really big. 4 over the square of a really, really big is really, really small, or 0. And it's x squared, so it doesn't matter if it's plus infinity or minus infinity, right? This is going to be a small positive. Well, in a sense, that doesn't matter because it's going to 0 anyways, right? So this is 2 over 1 minus 0, which is 2 over 1, or 2. So let's put that all together. I'll give you a second, and we'll just go to a new page. Okay, looks good. All right, so what do we have? As x approaches infinity, f of x approaches 2. As x approaches negative infinity, f of x approaches 2. So y equals 2 is a horizontal asymptote. And the graph. Okay, so we've got 3 asymptotes we're worried about, right? The 2 vertical asymptotes, the ones at negative 2 and 2, and then the horizontal asymptote at 2. So if we put together what we had before, we know that this was going up, and this is coming to here. So there's that sketch. We know on this side was doing this. And we know that this is here, and this is here, and, you know, here lie dragons. We don't know what's there. Okay. Something's happening there, but we'll figure that out later. And we sort of know what we should be doing, right, in order to figure it, but right now we're not putting that in. So that's what we've got, right? And as we sketch the whole thing, as we put it all together, we'll be adding a bit more to it, right? To say, oh, and then let's find this, that, and the other. Okay, so there's our horizontal asymptote at 2 and our 2 vertical asymptotes and the behavior around those asymptotes, right? Okay, so let's define this then a little more formally, right? The line y equals L is called a horizontal asymptote of the curve y equals f of x if either the limit as x approaches infinity of f of x is equal to L, or the limit as x approaches negative infinity of f of x is equal to L. Right? That's just the formal definition of an asymptote, right? So if there is a line such that the value of f of x is equal to L, or sorry, if there's a value L such that as x approaches infinity, f of x approaches L, then it's a horizontal asymptote. Okay, these aren't necessarily the same on both sides, right? It could be one value going to positive infinity and a different value going to negative infinity, right? So now, so far, we haven't seen that. You will see that there's a couple of questions in there, and I'm just going to give you a little reminder. If you want to see horizontal asymptotes, then look at page 215. For possible horizontal asymptotes, right? So what can happen? Okay, so if you look at page 215, there's a number of graphs on there, and you'll be able to say, oh, okay, yeah, this could happen or that could happen, right? There are just definite possibilities of what can happen. All right, so what we want to do to get horizontal asymptotes is basically determine the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x, right? So to determine horizontal asymptotes, let's spell it out. To determine the horizontal asymptotes, determine the limit, clean that up, the limit okay, so determine the two limits, right? The limit as x approaches infinity and the limit as x approaches negative infinity. All right, so let's do a couple of examples. Then we'll be done. Then you'll have time to work. Finish that. Give you a chance. A couple of new things, and we'll put it all together. We'll spend days sketching curves. Thursday, Friday, Saturday, Sunday. That's kind of tough coming back. Although, given this weather, where else is there to be? Okay, so example. All right, so as Mr. Kader said, we just look at it and go 3 over 5, right? But we can't just do that. That's the answer, so at least you know what you're working towards. Seeing as it's square, right, so we could do the limit as x approaches plus or minus infinity, right? Because it's only the term of highest degree that matters. So we're going to take 3x squared over x squared plus 1 over x squared. Right? So we're dividing top and bottom by the term of highest degree. 5x squared over x squared minus 2x over x squared plus 3 over x squared. Which is, let's go across. Okay, so what do we got? 3 plus 1 over x squared over 5 minus 2 over x plus 3 over x squared. Okay, which is, now we can drop the limit because we can actually work them out, right? So it's 3 plus 0, right? 1 over x squared is 0. So wondering if that's what pressing. Is it important? 5 minus 0 plus 0, which, as stated earlier, right, was 3/5, right? So the horizontal asymptote then is y is equal to 3/5, right? It's a horizontal line, so it's of the form y equals. Right? And that's all we were doing. There's no sketching this out, right? Okay, and that's whether you're going to positive infinity or negative infinity. Okay, both ways, it's 3/5. Okay, and over the next few days, weeks, months, years, we're going to put it all together into here's how you sketch curves.
Will you ever need to factor it out?
Or do physics. Yeah. What?
You won't ever need to factor it out, really.
No. Yeah, no, you don't want to do that. Well, I was just looking at. All right, so example 2.
This is where I'm like, I should do something.
Okay, so determine the horizontal and the vertical asymptotes of that and sketch the graph. Okay, so you see when we get into the formalized curve sketching, we're going to say, step 1, do this. Step 2, do this. Actually, they use A, B, C. Step A, step B, step C, and so on, right? And then you'll have figured everything out that you need in order to sketch the graph of the curve. Okay, so let's do the horizontal asymptote. Limit as x approaches plus or minus infinity. What's the highest power of x?
Yes.
Squared. So we're going to divide everything by x squared, right? Okay, so we get x over x squared. We got x squared over x squared minus x over x squared minus 6 over x squared. Okay, which is, oh, let's go this, we'll go over here. So up top, we get 1 over x. On the bottom,
That's me.
I think that was me.
That's my call.
Is it really?
No. Is it important?
No, it's not me. It's not for me. No, it's just a calendar reminder. Okay, so as x approaches plus or minus infinity, 1 over x is going to be 0. Over 1 minus 0, which is equal to 0, right? So the horizontal asymptote is y equals 0. Okay, that's the more formal way. So it's what you got to show on an assignment or a test way. Actually, no, we'll go to a new page and we'll do the vertical asymptotes. So the vertical asymptotes. You're going to start off by factoring it, right? So to find vertical asymptotes, we want the factored form of the denominator because we want the values of x that cause the denominator to be 0. And we can see that we will have a vertical asymptote at x equals -2 and x is equal to +3. So now we get to examine 4 things, right? We got to look at -2 from below, -2 from above, -3 from, +3 from below, +3 from above. So the limit as x approaches -2 from below of x over x plus 2, x minus 3 is, okay, so let's pick a number, right? We're going to use like -2.01. So what's the top here? It's going to be a negative, right? I mean, x is negative, so that's negative. You got a negative, something below -2 and you're adding 2, you're still going to be negative. And you got negative minus 3, so that's going to be negative. It's negative. And so the end result is negative infinity, right? Okay, got 3 negatives, makes a negative. All right, limit. As x approaches -2 from above. So what's the number? We're going to use like -1.99. So we get a negative, and we get a positive, and we get a negative. Right, so x is just, because x is negative, then x is negative. And then x plus 2, we're adding 2 to something that's slightly, you know, so it's going to be positive, and then we're subtracting, so that's going to be negative, and the result is the 2 negatives, you get positive infinity. Okay, remember your vertical asymptotes, what are the possibilities, right? They both go up, they both go down, or they go opposite directions. And we're going to do the same thing with 3, so x approaches +3 from below, so we're going to use like 2.99. And that's x. Okay, so we're working around +3, so the x value is positive. When you add to a positive, you get a positive. And when you're taking something that's just below 3 and subtracting 3 from it, you're going to get a negative. And the result will be negative infinity. And then, last one, the limit as x approaches 3 from above. So the example, say, okay, we're going to use 3.01 of, okay, what is it? X plus 2, x minus 3. Okay, well, that's positive because it's positive x, right? It's approaching 3. 3 plus 2, positive. And 3 bigger than 3 minus 3, positive. Okay, don't need positive there. And that's going to be infinity. Okay, so what's going on? Let's sketch it. Okay, sorry, move that back. Finish that. So lots of work to find vertical asymptotes, right? Because you got to figure out what's happening on each side of the asymptote. Which way is it? Are they both going up, or they're both going down? One going up, one going down. Okay, we take that information. We go to sketch it out. Okay, we have 1 at -2. We have +3. And we have y equals 0, right? That's the horizontal asymptote. So here, as we approach 3, we know what this is going on. And on this side, we know that this is going on. And in between, we don't know much, right? We know that this is going on, and we know that this is going on. Okay? But we don't know what's happening in between there, right? And we'll leave that. It's got to be something to do. And that's it, except one last thing. When you're doing questions, so there's questions 8 and 9, where you're doing a square root of like 2x squared and you're figuring out the limit. Now, that was on the first assignment, and there was a reference to a video, and that might not be terribly fresh in your mind, so you may want to review the video. So review, say this would be like for numbers 8 and 9, right? For 8 and 9, where you're doing the limit and you're using a root sign, right? The limit of 2 under the root sign, 2x squared, etc. Okay, so review video, and I'm going to give you a shortened link. So goo.gl, uppercase K, uppercase M, lower v, lower y, lower m, lower t. Okay, so that's just a shortened URL. If you still have the assignment, it's on the assignment, but it's like this, YouTube.watch question mark blah blah blah. So I just threw it in a URL shortener, and here you go. Other teachers knew they existed. I'm sure they would have done that for you. I tried a bit.ly, but it came up with like weird characters I couldn't read. Like, is that a 1 or an L? When I typed it in, it just went somewhere else. So then I went to goo.gl. Okay, so there you go. If you want to review that video, which tells you how to do limits as x approaches infinity or negative. So uppercase K, uppercase M, lowercase v, lowercase y, lowercase m, lowercase t.
Yeah, 6.